Hey guys, welcome back. Today we are going to do a short lesson on the properties of matter. And the good thing about this today is that a lot of it is just a little bit of a review because we've already talked about some of these properties. Now before we get into it, there's a joke on the screen. It says you matter. Unless you multiply yourself by the speed of light squared, then you energy. And of course, that's a joke because remember we're all made of matter. Because matter is anything that has substance and takes up space. Alright, so that's cheesy. Cheesy science jokes. Let's go ahead and get started today, guys. Alright, so just a refresher of what is matter. Matter is everything that's made of mass and space. So it has mass and it takes up volume. The sun, moon, trees, lakes are made of matter. So anything that has mass and takes up space. Some examples would be like rocks, frogs, air, pizza. Anything that you can think of that has mass and takes up space is matter. And even you matter. And then here is a picture of just matter. These are just some pink fluffy clouds taking up space in that box. All right. So, we've talked about properties, chemical and physical properties, and when we're describing objects, we can use those to help us give a description of whatever object we're trying to talk about. And so here's an example of two different kinds of paper clips. So even though these are both paper clips, so they're categorized as the same item, they have different properties because they're made of different materials. So if I were to ask you to describe a difference, the first thing off the bat we notice is probably the color. So the paper clips on the left are different colors. We have red, green, blue, yellow. And then the paper clip on the right is just a silver. You could also tell me about the thickness of the paper clips. The ones on the left are thicker and the one on the right is thinner. If you were able to hold these paper clips in your hand, they might have different textures because to me it looks like the ones on the left are flat whereas the one on the right is more rounded. So just because two things are similar, like in the same category of what we itemize them at, it doesn't mean that they have the same properties. So remember that physical properties are characteristics that can be observed and measured without changing the chemical makeup of the substance, right? So we're not changing the chemical makeup. So these are just a few properties just to refresh ourselves and make sure we know about them because we are going to have a quiz and we're going to have a test on physical properties or matter coming up soon. So malleability is the ability to be hammered and molded without shattering. Remember, metals are malleable. So we talked about the difference between metals, nonmetals, metalloids. Metals have malleability. So let's think about graphite and marble. So graphite is what is used in like lead pencils that you write with. And also marble, think about like sculptors use marble. So that would be malleable. Because again, malleability is the ability to be hammered and molded without shattering. Marble technically is pretty fragile, but it can be molded, it can be sculpted. So think of sculptors with their marble. And also metals are malleable as well. Ductility is the ability to be stretched. So we have a picture of copper wire. Remember I said in your last lesson that metals are very ductile. They can be pounded into thin wire, stretched out. That's just what ductility is. Okay? So then let's think about wood. Would wood be ductile? Give it a think. What do you think? The answer would be no. Wood is not ductile. It can't be stretched out. It has maybe a little bit of plasticity in it, but you're not going to be able to take a beam of wood and stretch it and roll it into a thin wire. It just doesn't work that way. So wood is not a metal. It's not ductile. Remember, ductility is a physical property of our metals. Elasticity is a physical property. That's the ability to go back to the original shape after being stretched. Really good example of elasticity is just a rubber band. Hair ties, if you use them, they have elastics in them. You stretch them out and then they will go back to their original shape. Now with like rubber bands and all things, eventually if you overstretch it, it'll lose some of that of its original shape, but for the most part it will go back into its original shape, which is elasticity. Viscosity is the tendency of a fluid to keep flowing. So if you were going to describe like a liquid to me, you could describe its viscosity. And this one can be a little bit tricky because a higher viscosity means that it flows slower. So let's think about, we'll take the example of honey and water. So think about honey, it's really thick. Typically it flows really slowly, and water in its liquid form will flow pretty quickly, right? So the honey would have a greater viscosity. So we would say honey has a higher viscosity than water. And we have a question here. It says, how does temperature affect viscosity? Typically, when you heat a substance, the viscosity is going to lower, meaning that it's going to flow easier. So if you think about taking honey, if you put some honey in, a pot on the stove and heat it up, typically it's going to lose some of that slow flowing, and it will start to run a little bit more. Same thing with like maple syrup. If you think of like going to get like pancakes or waffles on a Saturday morning and the waitress brings the syrup around, if it's heated, it's going to flow a little bit easier, so that viscosity is lowered. Hardness is how well a substance can scratch another, or how easily it can be scratched. There's something called the Mohs hardness scale, and typically when we use that when we think about rocks and minerals. So a low on the whole Mohs hardness scale would be like talcum powder, like baby powder. So it's very fine, doesn't do a lot of scratching. And then on the other end, we would have like diamonds, and diamonds can scratch other substances. They can scratch window panes, and they have the ability to scratch. And then finally, the last thing we're talking about in terms of a physical property today is density. And now density, we're going to get entire lessons on density. I just wanted to intro it to you today so we just know what it is. Density is the ratio of the substance's mass compared to the volume. So we can actually figure this out using a mathematical equation. And density is just mass over volume, so M over V. And you guys are going to get very familiar with this in our next couple of lessons where we take a look at density. Okay? So that's it. That's just a reminder of physical properties of a substance, right? We've already talked about some of these when we talked about metals versus nonmetals, but I just wanted to make sure that we were on the same page and that we reviewed the different physical properties today. All right. So that's it for today. You guys are welcome to move on in your lesson, and if you need any help or have questions, make sure you let me know. Bye, guys.